that I think you guys have already asked the Splunk guys, so my plan was to kind of work on the Splunk today. So maybe we'll take the same session in a separate session. Okay. And today what we do is that we stick out then just to the VAPT part. Okay.
Yeah.
And we try to complete. Okay, fine then. Fine guys. So what we do is that we discuss about the exploit development today. Okay. And we leave out the same tool for now. We take a fresh session on today because today I was not with the mindset on that thing. So we exclude this part and let's jump on to the exploit development. Okay. So let me quickly share a few things. So give me 1 second. Okay, so give me a few seconds, guys. I need to just, for the exploit, I need to just quickly grab certain links. So just give me 2 seconds. Okay, so what I'll do is that I'll jump directly to the Splunk since I was ready with the kind of Splunk deployment. So I will kind of exclude that. So kind of just give me 2 minutes. Let me quickly warm up with the exploit thing. Let me just quickly grab the links for that. So just stick out for a few seconds.
Actually go on to a live demo of examining memory stack registers, etc. using a very simple C program and GDB.
Okay, guys, and just give me 1 more minute. I'm almost there. Just setting up the lab for the exploit thing. Just give me a few seconds more. Okay, guys, so I'm start. I'll just now quickly start now. Let me quickly set the screen. Okay, so now what we'll be kind of doing is we'll be kind of understanding the exploit development in a much deeper way. And thing is that it will be a combination of both Metasploit and uh, exploit development using, let's say, using Python. But we will not be fully dependent on the Metasploit. We'll just use one of the module of the Metasploit, but we will not kind of dip, and like the way by which I'll be kind of approaching this will not be depending wholly on the Metasploit. Okay, so let me quickly. So I hope my screen is visible, and now let me quickly start with that. Okay, so the first thing which kind of I have planned is that I will be kind of first explaining a bit about the assembly language. So thing is that when the exploit development is done, so it's we need to kind of work at the assembly level, and and then it is not just like the kind of normal Python or C language that we use. Okay, so let me just quickly go to, I picked one video, but it just for actually kind of like it has few specific good figures, images and all, so that's the reason kind of I have picked this up. So let me just quickly go to the specific figure and start from there. Okay, so I'll quickly start with the basic ones. Let's say the first thing is that in any system we normally have, let's say, CPU, which you already know. Then we have the RAM memory, and memory can be, let's say, anything. It can be the and I hope I am audible. Just quickly see that. Yeah. So thing is that we have CPU, we have the RAM memory, and we have the input and output devices. Okay, input and output devices. I mean, let's say the hard drive, or let's say keyboards or mouse. So those are three things at a very basic high level. And this is how the thing is, like they are all connected with each other, and this is how, like let's say, they communicate with each other. Let's say, so there's a system bus, and bus just treat it like kind of a road. Okay, treat it kind of a road, by which CPU can kind of share data between the CPU and the memory, or let's say memory can share data, kind of interact with, let's say, the IO and devices. In similar way, each of the three component can kind of talk with each other, which is what the system bus is all about. Okay, so this is at a very high level, kind of how the kind of computer architecture is all about. Okay, so what we do is that, and now thing is that so I hope you got, so this is something I hope everyone is very comfortable. They should be kind of knowing that how the computer looks like at a very high level. It's has CPU, it has the memory part, and it has the IO input devices. And now let's jump to the CPU part, like what else is in the CPU part. Okay, so during the exploitation, what we normally do is that we depend more on the CPU part, and we try to understand what CPU has uh, at a very kind of uh, at a more in-depth level, what CPU is all about. So CPU has kind of, let's say, four different kind of units. One is the execution unit, and then it has control unit, then it has registers, and then it has kind of flags. Okay, and execution, I mean, is the part where the chips, where the actual calculation actually happens. Let's say if there's any instruction like a equal to 5 plus 6, so that addition will take part in the execution unit. Okay, now there is something called as control unit. It is actually related to kind of retrieving or decoding instruction, or let's say retrieving certain things from the memory. Let's say, for an example, there are 10 lines of code, for an example, and let's say the first line was executed by the CPU, and then to fetch the next line that needs to be executed, the control unit actually has the CPU in kind of fetching that from the RAM memory one by one and getting it executed on the CPU. Okay, so that's what the